Welcome dear civil engineering students. Today I will be teaching you how to design the dog-legged staircase as represented in the following figure. So here you can see that this portion is landing portion. This is landing portion. It is supported on walls by on all the sides. It is supported by walls. The width of the landing is 1.25 meter, and this portion is the going portion, or it is also called as flight. Okay, this is flight, going, or it could be called as flight. Now the span of flight is 3.3 meter, and the width of the landing portion is 1.25 meter, and this length of the landing is 2.8 meters. We'll see how to design this. Now this table is available in IS 456-2000. There are 4 cases. Now suppose you take that x is less than 1 meter and y is less than 1 meter. In such case, the distance from this point of the landing to the other side of the landing is nothing but g plus x plus x plus y. Now suppose you have a condition where y is greater than 1. So if y is greater than 1, greater than or equal to 1, here you replace this y by 1. Suppose if x is greater than or equal to 1, you replace the x by 1. So here x is greater than or equal to 1. This is the third case. In the fourth case, if x is greater than or equal to 1 and y is greater than or equal to 1, you can definitely write here as g plus 1 plus 1. So these are all the 4 cases, and which is represented by this table. This table is available in IS 456-2000. Now you have to understand this figure. What I shown here is this is the waste slab. So this slab is the waste slab. This is the slab which is called as waste slab. So the purpose of waste slab is to provide support to the staircase which is provided above. So this is the staircase. In the staircase there are 2 parts which is said to be tread. So this is tread and this is rise. Okay. Now tread is 1 feet dimension and the rise is 150 millimeter, that is half feet. So rise is half feet and the tread is 1 feet in dimensions. So this is the angle that the rise makes with the d effective depth d, and this angle are both equal by the property of triangles. Now this t millimeter is nothing but thickness of the, so this is t, which is the thickness of the waste slab. Now what is b? B is nothing but b, you can calculate the width of the staircase as square root of r square plus t square. This b is the width of the staircase. So from this point to this point, the width is b meters. Now if you add t with r cos theta, you will be getting the value of effective depth d. Okay. So these are the basic things that has to be understood while designing the staircase. Now if you have any doubts, you can mention in the comment section. So you can see that this b is r square plus t square to the power 1 by 2. Now basically from this point to this point, this is the width of the staircase which is supported by the waste slab. Now along the other dimension, suppose you are building the staircase, the stair will go like this. Okay, this will go like this. So this length would be 0.8 meter, or it would be 1 meter, 1.2 meter, and so on. Okay, so no need to care about the third dimension. We will take the third dimension as unity. Now what is given here, we have to first calculate the effective depth. Before that, we have to calculate the effective length. So we have to calculate from this point to this point what is the length. So here you can see that this length, this width is 1.25 divided by 2, and this is 1.25 divided by 2. So this is nothing but y, and this is nothing but x. X is less than 1 meter and y is less than 1 meter. So you can take the effective span as the x plus g plus y as observed from the table from IS 456. So that is calculated here as 4.55. Now what is the effective depth? Effective depth is 1 by 20 to 1 by 25 of the span. So if you do that, you will get small t as 200 mm, which is the thickness of the waste slab, and overall depth you can assume to be 230 millimeter. You understand? So this is how we calculate the effective depth. So effective depth is calculated as 1 by 20 to 1 by 25 of the span. So span, that is, what is the span of the staircase? The span of the staircase from this point. So from this point to this point, that is said to be span of the staircase. That is obtained to be 4.55 meter, and you divide this by 20, you get around 200 millimeters, and overall depth could be kept as 230 millimeters. Now again here we have to calculate the loads. So how will we calculate the load? First we will calculate the waste slab. So waste slab, we can see that the waste slab is something like this. Okay, so this distance is B. This is nothing but T. So this area is calculated as, here, weight of the waste slab, as this B is nothing but square root of R square plus T square, which is shown here. This is B, this is T, and you divide it by the tread. Okay, that is 300, that you divide it by T to get it in kilonewton per meter. So B into T divided by T is the formula used here, and you multiply it with 25 kilonewton per meter cube, which is density of the RCC. So after doing all the calculation, you get 6.42 kilonewton meter. Then again taking the case of weight of the steps, the step is just like this. The step is like this. So you have to calculate the area of the rectangle, triangle. So this is 0.3, this is 0.15. So how will you calculate the step weight? You will calculate, like, first you will calculate the area. So half into 0.3 into 0.15, then you divide it by 0.3 to convert it for 1 meter, multiply it by 25 kilonewton per meter cube, which is said to be 1.875 kilonewton meter. You add these two, so it will give the weight of this whole portion. Now it is 8.30, and if you have some finishing, approximately you can take it to be 9.25 kilonewton per meter. That is 1 kilonewton per meter approximately is added to the dead load, and this is the dead load with finishing. So finally we have calculated the dead load with finishing. Next, on the going we have calculated 9.25 kN, and then on the landing slab. So if you take the landing slab is just like this. This is the landing slab, and you have here we have to calculate the weight of the slab. So how will we calculate the weight of the slab? First you take the so if you draw the landing slab in 3 dimension, this is the landing slab. Now what you have to do is the thickness of the slab is obtained to be 0.23 meter. Now for 1 meter width we are going to calculate. Hence it is nothing but 0.23 into 1 into 25 kilonewton per meter cube. So you get 5.75 kilonewton per meter. Now if you add 1 kilonewton per meter for finishing, you will get 6.75 kilonewton per meter. Now live load is 3 kilonewton per meter square for the residential buildings and normal buildings. You can take 3 kilonewton per meter square. Then factored load on going for 1 meter width of the stair. You understand that it is for 1 meter width of the stairs. Okay, on going it is 9. This is dead load. This is live load. So 1.5 times dead load plus live load, which is 18.375, and 1.5 times 6.75 plus 3. This is dead load. This is live load. You get these things. Now then we have to here take this going and landing, and you apply this loading to the going portion. This loading 14.625 kilonewton per meter is applied in the landing portion. Now this is the case, and from the fundamentals of the structural analysis and Sathyabama, which you already know, since this loading is symmetric, half of the loading will come as the reaction at this point, and the other half will come as the reaction at this point. Then you can see that the shear force at this point is maximum, which is said to be RA, and here the shear force is maximum. RA is equal to RB because the loading is symmetric. Then after that, what we have to do, we have calculated RA and RB. Once you know RA and RB, you can calculate what is the moment at the center. So that you calculate from the fundamentals as 46.82 kilonewton meter, and limiting moment of resistance calculated from the code is 0.138 FCK BD square, which comes around 110.4 into 10 power 6 Newton millimeter. Hence you can design it as singly reinforced section. Now refer class 38.1 of Annex G to calculate the AST. So this MU you substitute it here. Then you will get what is the AST. Okay. So finally, if you substitute the value of moment and in this equation, you will get the AST. So this is the AST 699 millimeter square. Now how to calculate the spacing? Calculating the spacing is very simple. Now whatever AST you are getting, that is for 1 meter of the portion. So if you want the spacing of the 12 mm bars, we have to calculate here for AST. The spacing is 1000 millimeters, that is 1 meter. Okay. Now then the logic is for 5/4 d square, what is the spacing? Okay, so this is the formula used to find out the spacing, and it comes around 161.8 millimeters. Then after that you are using the 12 mm bars at 150 millimeter center to center, and the distribution steel is given in given in page number 48, class 26.5.2.1, which is 0.12 percentage. So you can here take 0.12 by 100 into 1000 millimeter into 200 millimeter, which is 240 millimeter square. Provide 8 mm bars. So use this same formula for this 8 mm bar also, and for 12 mm bar also you have used the same formula. Okay, then you obtain the spacing. So spacing is obtained to be 209 millimeter, which is confined to 200 millimeter. So you understand that 12 mm pi bar is used for main reinforcement, and 8 mm bar is used for the um, distribution reinforcement. Now that design of flight is over, now we design for the landing slab. Okay, now the length of the landing slab is calculated as the center to center distance between these 2 points. So you can see that this length is 2.8 plus 1.25, sorry, it is nothing, it is 0.23 by 2 plus 0.23 by 2. So it comes around 3.03 meter. Now the factored load is 14.625 kilonewton per meter. Now here you can imagine that the moment per width is WL square by 8. Now here it is considered to be the UDL. So the UDL will be something like this, acting WL square by 8. So this is 16.78 kilonewton meter. Then you substitute this here and find out the AST. AST equal to 238 millimeter square. Provide 8 mm bars at 200 millimeter per center to center. You can see that this landing slab, it bends in this direction. Okay, in this direction it bends. Now the UDL has been obtained to be the 14.625 kilonewton per meter, and the center to center distance. So here you can see that the UDL is like this, and this distance is 3.03, and finally the maximum bending moment diagram will come like this, that is WL square by 8. This is WL square by 8. Now once this MU is obtained, you refer class 38.1 Annex G of IS 456 page number 96. Then using this expression you will get AST. Once you solve AST, you provide 8 mm bar, and the spacing also you can calculate, as I mentioned in the last slide how to calculate the spacing. So spacing is equal to 1000 millimeter by AST multiplied by pi by 4 d square. Now this is the reinforcement detailing, where you can see that uh, this bar is 12 mm bar. So you can see that this bar is the 12 mm bar, which is provided at a distance of 150 millimeter center to center, and this bar, which is perpendicular and lies above this main reinforcement, is like this. This bar is the 8 mm bar at 200 millimeter center to center. And similarly here, if you see, this landing slab is provided with the 8 mm bars. So here you are providing the 8 mm bar. Okay. So this is how we give the reinforcement detailing. Thanks for watching. If you have any doubts, you mention in the comment section. Thank you.